Now, to get back to our particular example, z equals 10 minus 5x minus 2y. How are we going to draw that? Well, there is a trick for doing that. If your plane is not vertical or horizontal, the trick is to first draw what are called the traces on the xy plane, the xz plane, and the zy plane. And I'm going to try to make that a little more intuitive by calling it on the floor, the back wall, and the left wall. Let's see, what are we drawing again? 10 minus 5x minus 2y, okay. Now, what the trace is just the line where the plane cuts the coordinate plane. So, for example, if we look at the floor, which is my name for the xy plane, the plane we're trying to graph is going to cut through the floor in some way. How can we figure out how it's cutting through? Well, on the xy plane, your z coordinate will be 0, because z tells you how far up and down you are from the floor. So to figure out what that looks like, we put 0 in for z, and ask ourselves, what would this line look like? So this line is going to be on the floor because I'm forcing z to be 0. Let's add 5x and 2y to both sides of this equation to make this look a little more familiar. So now this is just the equation of a line in the xy plane, and the easiest way to graph this line in the xy plane is to graph the intercepts. So if x is 0, so in other words, the x term is gone because x is 0, then y has to be 5. On the other hand, if y is 0, so the y term is gone because we put a 0 in for y, then x has to be 2. So what is this line going to look like? Well, its x-intercept is 2. Its y-intercept is 5. And the line connects those two dots. So that's the trace of the line, of the plane rather, in the xy plane. If I were able to see this plane, I would see it cutting through the floor along that line. Now let's look at the left wall. In other words, the xz plane. My plane is going to slice through that left wall along some line. How can I find that line? Well, if I'm on the left wall, my y-coordinate is 0, because the y tells you how far to the left and right of the center you are, how far to the left and right of that left wall you are. So if I put a 0 in for y in my original equation for the plane, z equals 10 minus 5x, and the y is gone now because I put a 0 in for y. What does that look like? Again, I'm going to use intercepts. And for me, it's easiest to have the variables on one side, but your mileage may vary. So I've added 5x to both sides. So we have 5x plus z equals 10. If x is 0, z must be 10. And if z is 0, x must be 2. So our intercept on the x-axis is at 2, which we actually already knew, but this is a nice kind of check to make sure that we haven't made a mistake somewhere. Okay, and the intercept on the z-axis is going to be at 10, and the line joining them is how our plane is going to intersect or cut the left wall. Last, the back wall, which is what I call the YZ plane. That is where x is 0, because x tells you how far out in front of the back wall you are or how far behind it you are. So if I put 0 in for x in my original equation, I have z equals 10 minus nothing, because I'm putting a 0 in for x. So z equals 10 minus nothing, and then minus 2y. And again, as I've said, for me it's easiest to get the variables on one side. So if I add a 2y to both sides, I have 2y plus z equals 10. The intercepts, if I put a 0 in for y, then z will be 10. If I put a 0 in for z, y will be 5. Which again confirms our previous calculations and also lets us know that the line that our plane is going to intersect that back wall in is that line. So there we have a visual. You can't see the whole plane, but you can never, of course, see a whole plane because it goes infinitely far in every direction. But if you picture, I don't know, a sheet of plywood leaning up against the corner of a room, this plane that this triangular sheet of plywood defines is the plane, even though it extends behind the back wall and to the left of the left wall, and of course below the floor.